Hi everyone, I am Madam Rosmaya. Welcome to my YouTube channel. So in this video, we are going to use the dimensional method to derive the physical equation. So from experimental observations, a physical quantity may be found to be dependent on a number of other physical quantities. Example, the physical quantity 1 may depends on physical quantity 2 or physical quantity 3 or physical quantity 4 or more. So it may depends on more than one physical quantities. So for further discussion, we are going to concentrate on this example. Okay, we read together the question, okay, the example given. So let's say the velocity v of waves in a liquid, okay, depends on the wavelength lambda, the surface tension gamma, and the density rho of the liquid. So derive an equation to relate the gamma, lambda, gamma, and rho. Okay? So the wavelength, surface tension, and the density. So let's say in this experiment, the following values for the velocities and wavelength are obtained. Okay, the given here is the data for velocities and the wavelength. Okay, and we are going to draw a suitable graph to deduce the value of the constants of proportionality in our equation. Okay, and given that the density is 1000 kilogram per meter cube and the surface tension is 4.30 Newton per meter. So we first to solve this question, we are going to derive an equation. The first question is to derive an equation. So we are going to use dimensional method. Okay, so the velocity given here, v of a wave, okay, depends on, this is the symbol for depends on, okay, depends on gamma, depends on wave, lambda is the wavelength, okay, and surface tension and the density. So we don't know how the velocity depends on, whether it is inversely to the wavelength, example wavelength, or inversely proportional or directly proportional, or can be any form of depends on the power of x here, lambda to the power of x. So if v is inversely proportional to the wavelength lambda, so the x may becomes a negative 1. If the velocity here directly proportional to the wavelength, so the value f of x here is 1. So we don't know how it depends on wavelength, so we just simply put as x value. So we are going to determine this x value. Same goes to the surface tension here, gamma. So we don't know how v depends on the surface tension, so we just put the power here as y. And for the density rho, so we use the power here as z. So we can say that velocity of the wave depends on lambda to the power of x, gamma to the power of y, and rho to the power of z. Okay, now using mathematics rule, so we put this gamma as equals. So when we put gamma as equals, we must put together the constant, and let's name the constant as k. Okay, so now the equations become v equals to k, lambda to the power of x, gamma to the power of y, and rho to the power of z. Okay, this one we use mathematics rules to convert the first statement to the second statement. Okay, when you put equals, to replace the depends on symbol here, we must put together with a constant. So this k is called constant of proportionality. So we are going to find this k value later after we form the equation here. The first question is to derive an equation. So we are going to derive the equation first. Okay, using dimensional method, So the dimension for both physical quantity, left and right side must be the same. So we need to determine the dimension for V and dimension for the right side variables. Okay. So this square bracket means dimension. Okay, the square bracket means dimension. So the dimension for velocity, okay, velocity is the unit for velocity is meter per second, or the formula for velocity is distance divided by time. So therefore the dimension is length L, and the time we use dimension symbol T. So distance divided by time. Time, dimension for time we use T, and dimension for length, for dimension for distance we use L. Okay, next is the wavelength. K has no dimension. Okay, so the dimension for K no need to write. And dimension for wavelength. So wavelength, the unit is meter. So the dimension for wavelength is L. So L to the power of X. Dimension for surface tension. So surface tension is one type of force, tension. So this is a force. So we use dimension for force. And okay, surface tension given uh, in the question. Go back to the question. So the surface tension here, the unit is given Newton per meter. So from here we can determine the dimension for the surface tension. Newton is the unit for force, and meter is the unit for dimension length. So that's mean for Newton we use dimension for force. So the force is MA. We can use formula MA. So M is the mass. Dimension for mass is M, and the A, acceleration, dimension for acceleration is L per T squared. From unit is meter per second per second. So the dimension will be length per meter squared. So the dimension for time just now we use T. Then for meter is L. Dimension for unit meter is length. So now we simplify this. We get M. L, the power of L here is 1. 1 minus 1 will be 0. So L to the power of 0 is 1. So therefore the dimension for surface tension is given by M per T squared. Okay, so we substitute into here. Don't forget the power is Y. And lastly is the density. So the formula for density is mass per volume. So that's mean we use dimension mass M, and the volume is length cube, because for volume is let's say for a cuboid. So we has length time width time height. So all has same dimension length. So we use length cube. And from the, if we use the unit for volume is meter cube. So meter, dimension for meter is length L. So we use L cube for the dimension of volume. Okay, don't forget the power here Z. Okay, now both side, left and right, must have equals dimension. Okay, must have equals dimension. Okay, we use dimensional rules. Okay, so for the both variables to be equals, their dimension must be equals. Okay, so for length example, okay, length, we simplify this first. So here x for length here is 3 times z. So means m to the power of z, L is to the power of 3z. This one remain the same. Okay, this one also we expand. Here means 1 times y, m to the power of y, t to the power of negative 2y. Okay, we use mathematics rule to expand the bracket here. Okay, now simplify for x, for L. L is x minus 3z, because this one is division, so x minus 3z. Then M we have Y and Z. So both is at the top. So that's mean the power plus Y plus Z. And lastly T. Okay, T is only one T here. So T remain the same. T to the power of negative 2Y. Okay, now we have simplify the dimension here. So left and right will have same dimension. Okay, both variables. Okay, now we are going to equate the indices for we have T here, we have M, and also we have L. So we are going to equate their indices. Okay, first for T. Okay, for T, on the left side, the power here is negative 1, and for the right side, the power here is negative 2y. So we equate them and solve for y. So y is equals to the 1 per 2 or half. Okay, next we do the same, equating the indices of m. Okay, so on the right side, the power for m is y plus z. On the right side, no m, so it is understood that the m here is to the power of 0. Because m to the power of 0 is equals to 1. Okay? So that's mean 1 times L to the power of 1 times L per T. Okay, we still get L per T. Okay, so that's mean the power for m on the right side will be 0. So equate the indices of m, we get this, and substitute y into here. So therefore we get z equals to negative half. And lastly, we equate the indices of L. Okay, so for L, on the right side, x minus 3z. Okay, on the left side, on the right side, the power here, nothing means 1. Okay, so equals to 1. And we substitute z into the equation here, z. So solve for x, we get negative half. Okay, so the next step is we are going to complete the rewrite the equation here by substituting the y, z, and x value, okay, into the equation here. Okay, so we substitute x, y, and z into the equation, and we rewrite this. The half means square root, so we can write as gamma, okay, square root of gamma, and the negative here means per lambda rho, okay, because negative. Okay, square root of gamma per lambda rho. And k is still a constant of proportionality, so we can write here as k. Okay, so done for the equation. We have derived the equation that relates V to gamma, the surface tension, lambda, the wavelength, and rho, the density. Okay, this is the equation. So we know that how V and wavelength relate with each other. So V is square root of here, depends on square root of gamma. Okay, for lambda, V depends on the square root of 1 per lambda. And how V and density relate with each other. So V depends on the square root of 1 per rho. Okay, this is how they depends with each other. Okay, done for the second part. Okay, next we are going to determine the k value. Okay, so we keep this first because next we are going to determine the k value. Okay, for k value, after we've done experiment and we get the set of values v and lambda. Okay, so we are going to plot a suitable graph to deduce the value of this k. Okay, this k, constant of proportionality. Okay, So how to draw the graph? Okay, how to draw the graph now from this data? Okay, we refer to the equation we have derived just now. Okay, from the equation, we rearrange the v and gamma. Okay, so the gamma is gamma per row one side, because gamma is a surface tension, and it is a constant value, 4.30, right? Constant value, and then still also constant is the value is 1000, and k also is a constant, so we put one side together. So the variables is v, okay, v here, 5 set of values v, and the wavelength also 5 set with the corresponding value from v. Okay, so v change with wavelength. So the v changes, so the wavelength also change by this value. The rest k, gamma and rho is constant. Okay, so the lambda is 1 per square root of lambda. Okay, square root of 1 per lambda, and square root of 1 is equals to 1. So we can write as 1 per square root of lambda. Okay, so now we compare this with a straight line equation. General equation for a straight line is y equals to mx plus c. Okay, so in this equation we have no c, so that means the equation is in the form of y equals to mx, straight line that pass through the origin if you plot the graph. Okay, so that means the suitable graph to be drawn for y-axis is v. Okay, y-axis represent v, and the m, the gradient, is this constant value, k square root of gamma per row, and the x will be 1 per square root of lambda. Okay, 1 per square root of lambda. Okay, now we are going to plot the graph. Okay, so the graph we are going to plot is y against x. Okay, so we add another column here to determine 1 per square root of lambda, the x value. This is y value, this is x value, represented by 1 per square root of lambda. So for lambda 8.50, so we substitute into the lambda, the equation here. So 1 per square root of 8.5, so we get 0.34. So we do the same for the next lambda, 6.20. So 1 per square root of 6.2 is 0.4. Okay, next 1 per square root of 3.9, we get 0.51. And 1 per square root of 2.2, we get 0.67. And lastly, 1 per square root of 1 per 3, so we get 0.88. Okay, so this is all values of 1 per square root of lambda for 5 set of data just now, v and lambda. Okay, so this is y, this is x axis. This is for y axis. So we are going to plot the graph now. So this is y-axis represented by v, and the x-axis 1 per square root of lambda. Okay, and the unit for v is meter per second, and the unit for 1 per square root of lambda will be centimeter, because lambda is given in centimeter. So the unit here will be centimeter to the power of -half. Okay, so for the first value is 2.30, okay, and 0.34, 0.34 somewhere here. Okay, next set of y and x value will be 2.7 and 0.4. Here, 2.7 and 0.4. Next is 3.4 and 0.51, and 4.50, 0.67, and the fifth set of point is 5.9 and 0.88. So we draw the straight line. Okay, this straight line pass through the origin, but I didn't draw the scale of y exists until 0, because not enough space. Okay, so I draw the straight line for these 5 points only. So if you draw the Cartesian plane until 0, zero value, so you will see that the graph pass through the origin. Okay, okay, next step. Okay, this is straight line pass through the origin. Okay, next step is we are going to find the gradient, m, the gradient of the graph. So the gradient of the graph is equals to the k to the power of gamma per row. Okay, so the y and x exist done already. Next is the gradient. So from the graph, okay, we calculate the gradient. The gradient is the vertical distance divided by horizontal distance. Okay, so we read from the graph here. We draw choose any 2 points on the line. Choose any 2 points on the line, and we calculate the vertical length. We get 3.30, and then the horizontal length of the triangle shown here is 0.5. Okay, so you will get the more accurate reading if you plot it. You plot the point here on the graph paper. So I didn't use the graph paper here. Okay, so this is the two values, vertical length and the horizontal length. So we get the gradient is this one, and make sure the unit is the same. So we convert the centimeter here to meter. Okay, the meter. So to convert the meter, so 0.5 times 10 to the power of negative 2. Okay, convert to meter. Okay, so now this is gradient. So we substitute into the m here. This is m. M is symbol for gradient. Okay, so we substitute this into here. Okay, equate it to k square root of gamma per density, rho. Okay, so just change the both side. Okay, I change here because we are going to calculate the k value, constant or proportionality. So we bring this to the right side, become here square root of density per gamma. Okay, we bring this to the right side, and then we substitute the 1000 and 4.30 into the equation here. These two into the equation here. Okay, so the k has no unit. So if you put together all the unit here, we can prove that k has no unit. K is the constant of proportionality with no unit, because the kilogram here can be cancelled out. The meter, all this meter here also can be cancelled out. Okay, and lastly the s, the time, unit for time, second, also can be cancelled out. Okay, so the answer for k is 1.01 times 10 to the power of 4, no unit. Okay, so done for the question, the second question, which asks for the constant of proportionality. K is the constant of proportionality. Okay, so this is the answer, our answer for this question. Derive the equation using dimensional method. So we get this equation, and then to complete the equation, we need to find the constant of proportionality by using the data given, drawing the graph, and from the gradient, we calculate the k value, constant of proportionality. So we have a complete equation for velocity, which is equals to 1.01 times 10 to the power of 4 square root of gamma per wavelength times the density, rho. Okay, so that's all for the video. Thank you for watching.